evaluate the integral of x squared over the square root of 4 plus x squared. This is going to be, again, a trigonometric substitution problem. It's pretty easy to see that this falls into this substitution, the type of square root of a squared plus x squared, where a is going to equal 2, because 2 squares equal to 4. So this is going to tell us what to do. What we'll do in just a second, I think this is a pretty insightful problem to work through, because it actually will tie a lot of things together, because we'll see not only will we have to do trig substitution, but we'll also have to do integration by parts to carry out the integration. Okay, so without further ado, let's start writing down things. So we know we want the substitution x is equal to 2 times tangent theta. So dx is equal to 2 secant squared theta d theta. And square root of 4 plus x squared. From this chart here, that's going to tell us it is equal to 2 times secant theta. So let's see, what do we get when we write down all of this stuff here? So x squared, well, x is 2 times tangent theta, all of that squared. Dx is 2 secant squared theta d theta, and this square root down here, we replace it with 2 secant theta. Okay, so what do we see here? That pair of 2's cancel out, and there's a factor of 4. That should come outside the integral. We have 2 tangents upstairs. And then we have a 2 secants up square, 1 secant downstairs. So right now we have, we want to evaluate the integral of 4 times tangent squared theta secant theta. Okay, so let's take a moment to think about what's going on here. So this is now basically a 7.2 problem to do this, to evaluate this integral. So we don't have a factor of secant squared theta to spin off. That would be nice, because that could be, then we could substitute in u is equal to tangent theta, and then du would be secant squared theta, but we don't have a secant squared theta here. We do have a factor of tangent theta times secant theta, but then we still have a factor of tangent left over. It would be, if it was opposite, it was 1 factor of tangent, 2 factor of secant theta, then that could also work. So what do we have to do? The best thing for us to do would be to take our tangent squared theta and replace it with secant squared theta minus 1. And so now this is the integral we have to do, and we can split this up into 2 separate integrals. 4 times the integral of secant cubed theta d theta minus 4 times the integral of secant theta d theta. Okay, so this is where we are. We have 2 integrals to do. And so the more important one, so let's recopy where we are. More important, the more difficult one is going to be the secant cubed theta, because the other integral, that looks like a equal sign, that's a better minus sign here. So when we do the integral of secant theta, that we did this in the previous section, this just ends up as the natural log of the absolute value of secant theta plus tangent theta. Okay, so our goal right now is to do the integral of secant cubed theta. And the trick is that we're going to use integration by parts, where u is going to equal secant theta, and du is going to equal secant squared theta, sorry, that's not du, that's dv, is going to equal secant squared theta d theta. The reason that we make this choice here for dv is because it's easy enough for us to say that v, now, the integral, the antiderivative of secant squared theta, is tangent theta. Okay, and then we also know that du here, if u is secant theta, du is going to equal secant theta times tangent theta d theta. Okay, so where are we right now? This whole thing is equal to 4 times, so let's say that right now, we'll come back to the factor of 4 log of secant theta plus tangent theta. Let's say right now that we're just going to focus on evaluating the integral of secant cubed theta. This is our goal. Okay, so u times v is secant theta times tangent theta minus the integral of v du minus the integral of secant theta times 2 copies of tangent theta d theta. Well, guess what? We've got a tangent squared theta here. Let's rewrite that once again. Let's rewrite that as secant squared theta minus 1. So it might look like we're not making much progress here, but as before, it might look like we're going in circles, but we're going to be able to pull everything back together in just one moment. Okay, so where are we? We've got secant cubed theta is equal to secant theta tangent theta minus the integral of secant cubed theta plus the integral of secant theta. And just as so frequently happened back in integration by parts, section 7.1, that's the same thing here. So we move this factor to the other side. So 2 times the integral of secant cubed theta d theta is secant theta tangent theta. And then we know from up here that the integral of secant theta is natural log of secant theta plus tangent theta. And we want a plus c here to finish that off. And so dividing everything here by 2 tells us the integral of secant cubed theta d theta is 1/2 secant theta times tangent theta plus 1/2 log of secant theta plus tangent theta, and all of that plus c. Okay, so now it's time for us to pull all of the pieces together. So our original integral that we came up with was 4 times this integral minus 4 times that integral right there. So putting everything together says that our integral, the integral of x squared over square root of 4 plus x squared dx is equal to, so 4 times this, so that's going to be 2 secant theta tangent theta plus 2 times natural log of secant theta plus tangent theta, the absolute value of that. And then we also had to do minus 4 times this. There we go, plus c. So plus 2 times that minus 4 times that will give us negative 2 times that. Okay, so what's going on here? So now we just have to say, what is tangent theta? What is secant theta? What are those in terms of things that we have from our chart? So tangent theta will be x divided by a. So tangent theta is x divided by a is 2 here. Secant theta is 1 over cosine. Cosine would be a divided by square root a squared plus x squared. So the reciprocal of that would be the square root of a squared plus x squared divided by a. And so secant theta would be square root of 4 plus x squared divided by 2. So filling in all of the appropriate piece of information gives us 2 times secant theta, 4 plus x squared divided by 2 times tangent theta, x divided by 2, minus 2 ln absolute value of secant theta, 4 plus square root 4 plus x squared divided by 2 plus tangent theta, x divided by 2, and then plus c. Okay, so there's some simplification we can certainly do here. I think this video is long enough, so I think it's a good place to call it wraps. Let's kind of observe that this is a very good problem because of how to really well understand. Go home and try to work on this yourself, because we're doing trig substitutions here. Then we're doing, so that's section 7.3. Then we're doing trig integrals, like from section 7.2. And a lot of our calculations that we were doing was using integration by parts, which is coming from section 7.1. So lots of really good things to understand here from chapter 7.